All right, welcome. We're in day 2. All right, day 2. Yesterday we talked about volume of cylinders. Today we're going to talk about volume of cones. And when you think about a cone, there's a couple things I want to show you today that you're going to really have, I doubt, any issues with learning what a cone is. Let me draw that a little better. Oops, hold on, let me draw that. So your cone here, ice cream cone, there's all kinds of different cones you're going to see in the world out there, and there's times where you need to understand what the volume of that cone would be. Now, I'm going to also draw something very similar next to it, and I'm going to draw a cylinder. And you're going to see that the cone has very similar characteristics to the cylinder and what's going to happen with the volume of a cone versus a volume of a cylinder. Before I start, I want to show you a video of, let's see here. All right, so I'm going to show you this video, and I'm going to put it on mute, and I'm going to talk. So what he has is he has a cylinder full of popcorn kernels, and he has a cone with the exact same radius or even diameter, the exact same measurement of diameter for this cone, and also the exact same height of the cylinder is also the same height of the cone. So let me show you what's going to happen. You know, this gets the video is a little choppy. He's trying to talk while he's holding the camera, but we're going to see now that this cylinder is going to go ahead and fill up the cone, okay? And we're going to look at how much is left of the cylinder after the cone is completely filled. Again, the cone has the same exact measurements of diameter or radius. We're using the radius, right? Because let's remember the formula from yesterday. Volume equals pi times radius squared, which is the area of a circle, times height. So let me pause that right there. Now we're looking at this cylinder, all right? And we're looking at this cone. Okay. Again, same exact height, same exact diameter or radius. Now, look at how much of the popcorn kernels are left. Let's look at this cone. Do you want to think how many more cones do you think you could fill up to make this eventually be empty? All right, as we keep going through, let's see, let me fast forward them just a little bit. Now, second cone comes into play. All right, fill it up, fill it up, fill it up all the way to the top. And now you have this much left, and you have 2 cones full. So how much more do you think you can fill? Do you think you can fill up 1 more cone? All right, let's see. Last person, they're going to fill it up all the way to the top. And now, look at what we have. This visual is super important. Oops, let me pause it. All right, there we go. So now your cylinder is empty, and you have 3 cones filled. So this is how we're going to get to our formula. Kind of interesting. So 3 cones equals 1 cylinder. Okay. Remember, the volume of a cylinder is pi r squared, the area of the bottom, times the height, right? All right, let's go back now. Let's talk about our formula. So if we're going to have to deal with how many cones, again, equal a cylinder. So I'm going to draw my cylinder over here. I'm going to try to draw it as nice as I can. And we're going to assume, I know it's not perfect, but we're going to assume it's the exact same height as these cones. And what you just saw, the visual you saw, was that 3 cones equal 1 cylinder. Remember the formula for the cylinder, pi r squared times height, was the ability to fill in this whole cylinder was pi r squared times height. So for 1 cylinder to be filled, that's your formula. But what if I asked you, how much would 1 cone be? Not 3, but 1. Could I use this formula still? And some of you guys might be thinking of what you're going to do. I could still use this formula, but it's only 1. So really, I could take this formula and cut it into 3 different spots, and all I care about is only one of the 3 spots of the answer, right? So what kind of math does that mean? When I'm cutting something up and taking something out of it, am I dividing it by how much? 3 parts. Would that be the formula? And guess what? That is your formula. So the volume of a cylinder is going to be pi r squared times height. The same thing, that's a cylinder, but the volume of a cone, you saw that it was 3 different ones. You're going to divide it all by 3, and that'll give you one of those 3 of the cylinder, right? You're basically taking your cylinder, and it's 3 separate parts. And this is one cone, another cone, another cone. Does the formula make sense? Why you would divide it by 3 to get the answer just for one cone? Okay, I hope so. Because now we're going to get down to our work. So as I go through here, let me X out of this. And let's go ahead and deal with this first problem. So we're going to look at the first problem. We're going to see that we have a radius right here, which is perfect. And then guess what we have in here? Your height is this number here now. That goes from the middle here. So your height is 27. So again, volume equals your radius. Hold on, let's put pi first. Pi times radius squared, right? Times the height. All right, that's the volume of a cylinder. If this shape was a full-on cylinder like this, we would be fine. But it's not. It's a cone. So you're just going to take that number and divide it by 3. All right, go ahead and do that. And pull in your calculator. So I'm going to pull up the calculator. I'm going to go pi times 15 squared times, was it 16 again? 27 times 27. I get this answer, right? And then what if I said divide it all by, oh, that's not going to work. So that doesn't work. If I want to get fancy, I can put parentheses around this. And then I think I can go ahead and get the division sign. Divide it all by 3. And that's what we're looking for, okay? And that's the number we want, 6361.7. If you didn't do all that, if you couldn't figure out the parenthesis idea, could you take this number, 1905? Could you go 19085.17? And could you take that number and then divide it by 3? Of course. But if you wanted to get fancy, you could just go right here, hit the division of 3, and be good to go. All right, and you're going to get the same answer. Okay? Very cool. Let me clear this. Let's go to the next problem. So the next problem we have here, same idea, but now there's decimals involved. Okay? So let me X out of this, pull this up, and now we're going to go ahead and go, that's our radius, right? That's our radius. This is our height. So we're going to go volume equals pi times radius squared times height. And don't forget the end, all divided by 3. All right? Go to your calculator, go ahead and solve that. Give me an answer rounded to the 10th. The 10th. Let's work on our rounding again. All right? So let me pull this up. Let me go pi times, I think, was it 12.4? 12.4. Remember your squared button. Super easy. Oh, I'm going to put parentheses around this too. If I put parentheses around it, it just makes it much easier. And then I'm going to go times the height, which was 20.5. And then in my parentheses, I puts it all together and then hit division of 3. Okay? I said round to the 10th. That would be that 8. I'm going to round that. That's the 10th spot. So when I look at this, okay, and I look at the 8, we know this. We're going to look at that 5. 5 or more, raise the score. So my answer would be 3,300.9. Well, that's how we would bump it up. All right? Let's move along. Next one. All right, word problem. We can do this. So for this one, the mold of a cone, I always want you drawing this, okay? So the mold of a cone, draw your cone, has a diameter. Okay, we know how to deal with this. No big deal. Diameter of 4 inches, and it's also 6 inches tall. Okay, what is the volume of the cone mold to the nearest 10? All right, let's go ahead and set it up in the formula. Volume equals pi times radius. Hold up. Did I make a mistake here? Yes, Marusik, you made a mistake because this is 4 inches, and we know that's a diameter, and all we care about is having a radius, half the diameter. Remember that, okay? So instead of having 4 there, you are going to put a 2 there, 2 squared, and then times the height, all divided by 3, all right? Let's go ahead and round to the nearest tenth, it says, all right? So let's go ahead and do that. So it's going to be pi times 2 squared times 6. Again, I'm going to put my parentheses around all of this. This is what the cylinder would be. We're not worried about the cylinder because we're going to cut this into thirds. We're going to divide it by 3, and there's my answer. If I round this to the 10th, 25.1, am I going to bump this up because there's a 3 right here? Is that 1 going to turn to a 2? Nope. 4 or less, let it rest. So 25.1 would be your final answer. Okay, let's do one more. Let's do one more. I think you're getting good, and then you're going to do the quizzes after this. All right, so I want to do this one. This is our fun one here. Let me pull this up real quick. So this is kind of like the higher level type problem you're going to see of this. And don't let this mess with you. You are totally capable of looking at this and knowing what's happening. When you look at this, you hopefully can see that one part of this is a cylinder. Another part of this is a cone. So are they mixing the two lessons together? Okay, you're mixing day 1 and day 2 together. So when you're handling this, let's go ahead and just do the cone first. If I'm dealing with the cone, it's going to be pi times, what's my radius? Well, that spot doesn't tell me anything. It just tells me a full line there, right? But what about down here? Isn't that going to be the same as right there? So it's 15. 15 squared, right, times the height. What's the height? 21. All right, and plug that in and get your answer. All right, and let's look at the cylinder. If we're going to plug the cylinder in, so the cylinder is going to be, what's that going to be? Pi. And forget about, hold on, what did we forget about our formula here? You're going to divide all that by 3. This one's going to be pi times radius squared. We figured out the radius. What's the height? Times 26. Do you see that? 26. And that's all you need for the cylinder, right? There's no division of 3 on that one. And then let's go to the volume of the composite figure. This word composite figure, we did that before. They wanted the volume of the entire shape. So wouldn't you just take answer to A and answer to B, and wouldn't you just add those up and give me an answer for the composite figure? Why don't you guys go ahead and try all of that right now with your calculator and give me a final answer? All right, so if you look at this answer, I have, this is the cone, this is the cylinder, and if I put those two together, I get the volume of the composite figure. All right, so do the best you can on the quizzes. The way it's going to play out this week, day 3 for me will be a volume of spheres, and that's going to come out tomorrow. Then we're going to send home basically a quizzes that you don't get unlimited tries on. You'll get one try, and that'll be your test. That'll be your test for this week. And I'm going to send it Thursday. It'll be due Friday. And what I'm also going to do is I'm going to be putting a lot of stuff that if you need to make up assignments or any work, I'm going to put some quizzes in a different tab that says a complete to make up other assignments. Okay, guys? Do the best you can. All right, we're playing this day by day to figure out how things are going to go. Stay safe. Keep busy. You know, figure out different things. If you want to get extra practice, go in that tab and get some extra practice. Okay. All right, guys. I'll talk to you later.